In this video, I want to demonstrate an AI connected to an old school CPM machine and using CPM, running Microsoft Basic, etc. So let me talk you a bit through the environment. I have an MSI 8080 on the bench here. It's got, of course, an MSI CPA front panel. That's got the LEDs and control switches. There's a Z80 processor card. There's a Altair 882 SIO, I believe it is. It's just dual RS-232 ports. One of those ports is the serial terminal port for the console, and then there's a card called an FDC Plus. It's a modern card that emulates an original Altair floppy disk controller. The FDC Plus serial driver you see here is the interface for that controller. That controller talks over a serial line to the Windows PC. I've got two disk images loaded, a CPM bootable image, and just a BDSC. It means, let me go ahead and stop. Actually, I should connect over here first. Let's go ahead and connect the serial port here to COM13. That's the serial port on the Windows machine. I'm going to stop the Altair, or the MSI. I'm going to reset it. I'm going to run it. And there should have been a little bit of disk activity happen here, and there we are. We booted into CPM. So I'm going to go ahead and actually just close this out here. Bring Claude up to the top, and I'm going to ask Claude to run a directory here. So the CPM Operator Skill's already been loaded. Run a dir command on drive B. And let's see if it knows how to do that. It should. So it figures out what I want. It's going to send directory B:, and there it is. And if I open up the serial log, we've got a log file here that's showing what's being sent to CPM and what's being received from CPM. And of course, the command is echoed back, and then the contents. And Claude's analyzed the disk and just tells me it's a BDSC development disk. Run a dir A:, and we should see the disk A directory information appear here in the serial log window as well, and there it is, and there's the directory A information. Yep, same A as before. I've been running commands on here just to verify this will all work. I've got Microsoft Basic on this disk, and we have Lunar.basic. And the goal in this exercise is to have Claude load Microsoft Basic, load Lunar.bas, run the game, and figure out how to play it. So let's load MBASIC, load Lunar, run it, and play it. So hopefully that's enough. Let me start Microsoft Basic and run it. So it's doing that. There's a Python script that sits between Claude and the machine, and that's what you're seeing the input-output here is that Python script. So there it is. It's ran MBASIC, it's loaded Lunar, it's got the Microsoft Basic information. Do you want instructions? It said I'm going to say yes on how to play. We see the help text scrolling up here. Let me see if I can bring a little more of this into frame here. And it's already running the game. So seconds into the game, we're at 1 second, 952 feet. We've dropped from the 1,000, speed 50, so it's burning fuel. It burned 10 and 10, so that's why the fuel is dropping by tens. And we'll just let this keep running here and see what we get. So that should keep scrolling over there. Claude is analyzing the game as it runs it. Still at 40 feet a second with 120 full, 130 feet up. Needs to conserve fuel for the final braking. Let me coast a bit and brake hard on the surface. That's an approach. I've never successfully landed the Lunar Lander myself. I haven't played this game a lot. But what you're seeing here is Claude interacting directly with the CPM machine. And like I said, this is a physical CPM machine. It's not an emulated machine. It's got an actual processor card. I'll post some photos in this video of the machine. And an actual I/O card, etc. It's a physical machine. So let's just let it run the game and see what we get. So 70 feet, time to start braking harder. I need to kill 40 feet a second of velocity with 100 fuel. Gravity adds approximately 5 feet a second, so I need to burn aggressively now. Still awfully high up to be this aggressive with the fuel. 600 feet up and only 80 pounds of fuel left. This is going to be a spectacular crash. We'll see what it learns, because it will try again. Far as I know, this is the first time anybody has hooked an AI up to a CPM machine. If somebody's beat me to this, I'd be interested to be pointed at what they've done, video or blog or whatever. As far as I know, I am the first person to have done this. It was actually pretty simple to do. The longest time here was building the basic skills, letting it read PDF files, documentation, exploring disks, etc. So I've never seen it successfully land the lunar lander, because I've always killed the run sometime around now, or maybe when the second run just starts. Way too much altitude for that amount of fuel left. So one of the things that isn't implemented very well here is the Python script connects, runs something, gets the return back, and then disconnects. And so it's really slow, because it's got to instantiate Python time after time. And there's got to be a better way to do this. I just haven't explored it. Let me coast to save fuel for the final descent. Your velocity is going to be way too fast for 25 pounds of fuel. Well, that's the downward velocity, yeah. So anyhow, the altitudes were still way too high, 30 feet per second. Speed's increasing, gravity is winning. Time to start braking again before it gets out of control. This is going to be a crash, there's just no doubt. So it took a lot of time actually to, in the end, tweak those Python scripts to get, have Claude tweak them, where I could get this real-time output here to a log file. Because CPM uses a carriage return line feed, Windows uses a carriage return. We had to translate all that kind of stuff. So this looked somewhat accurate here, and it is a log file, is why it's getting a time date stamp on everything. It's using standard logging. Burn last 5 units of fuel, and then we will crash. So, and there it is. Bell, 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 ding, 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 out of fuel. Touchdown at 31 feet per second, or at 31 seconds, landing velocity 60 feet a second. Yeah, that was a mess. It's asking to try it again here. The problem is I burned too much fuel early maintaining a steady when I should have coasted longer and saved more fuel. Free fall most of the way and then burn. So let's see if it's correct here. Let's go ahead and say yes. You can run it again and see if it takes its own advice. Start another lunar mission. So it's answered yes, I'm going to run another mission. It's reset back up to 1,000 feet, speed 50. New game, strategist time, coast early, save fuel, brake hard near the surface, gravity adds 5 feet a second each turn, each unit of fuel removes 1 foot a second. I need to free fall until close to the ground, then max burn. So the velocity can't get above 150 feet a second, or 150 pounds of fuel cannot break it to 0. So I guess that's a strategy, but just extrapolating this out in my head, well, maybe as the velocity increases here, we'll get to something reasonable height-wise. In my mind, for this strategy to work. Yeah, this might actually work. As I extrapolate these lines out in my head a little further. So we've still got 70 extra pounds of fuel here. Now time to start max braking at 30 burn per second, reduced by 25 net. I need to kill 80 feet a second. Okay, yeah. Yeah, that's correct, because gravity's still trying to accelerate us down, so 30 pounds of fuel only decelerates you by 25 feet per second. So its altitude's still too high for this strategy. Come on, land that thing. Oh, he burned 3, and now he's going to let it start to accelerate again with 53 pounds of fuel left. So it's going to let it accelerate again. So there's gravity adding 5 feet per second. Claude's way smarter than the Lunar Lander software was. It should be able to manage this. Of course, I don't know how accurate the simulation this is. I assume it's incredibly inaccurate. Again, we can't get above 48 feet per second or we can't break to 0. So it's not going to pull it off. It's got 2 more turns than it has to start burning fuel. Although I guess you don't need an exact velocity of 0. I don't know whether 5 feet per second is a survivable landing, because it's got this one that'll get it 48 feet per second. Oh, it started burning fuel there, so it burned 30 pounds, which reduced it to 18 feet a second. With 23 left, it burned 10 pounds of fuel. Nope, this is a crash. It's already lost. It can't remove this velocity. 13 pounds of fuel cannot break 18 feet per second. It has lost. 13 pounds of fuel can only break 8 feet a second because gravity adds back 5 with the 1 second burn. So it is a loser again. So I've been spending a lot of time in Claude. I've been having it write CPM software in pure 8080 assembly language. I have a really good version of Tetris running on a Dazzler video card, which is really pretty cool to see. So I don't know if, what will that be? Minus 13, 25, 30 feet per second. Is that still your ship is a wreck, so it hit at 28 feet a second. Your family will be notified by post. So we didn't remove a mountain this time. The problem's clear now. I wasted 90 fuel early on, breaking from 80 down to 5, which was too high. Then I had to coast and rebuild speed, only to run out of fuel at the end. Not to approach coast until much lower. Then 1 massive sustained burn to touchdown. Yeah, go ahead and try again. If you're still watching the video, I appreciate you being here. So it should be answering yes. And we will try again. So I've been having Claude write a lot of software. It's been really interesting acting as tester in PM. The Dazzler video card was an S100 video card from way back in the 70s. We're running in a 64 by 64 pixel mode for breakout, and there's 16 colors available. And like I say, it's created a really respectable version of Tetris, which meets about 95% of the Tetris specs. So, ghosting and all the stuff is there. And it's really very playable. It's surprising that a 2 megahertz 8080 with a video card can actually play a decent game of Tetris. I'm really surprised. We've written a full screen text editor. Again, full assembly language that runs well on a 2 megahertz 8080. I've got an implementation of the original Atari Adventure I'm working on. There's a version of Breakout I'm working on that I'm not satisfied with yet. It doesn't play really well. Started a bunch of stuff. I don't know what it's thinking about here. So it's not doing a compact, so I'm not sure what it's thinking about. So I'll just keep jabbering here. Pretty impressed with Claude overall. It's done a really good job at the 8080 assembly code. The text editor, full screen text editor, source is 366K. There's a lot of comments in it, but that's a lot of source code, 366K. There it goes, starting a new mission. The executable, I want to say, is about 17K, and considering it's full screen with a number of features, block, you can mark blocks of text and copy and paste and all that kind of stuff. And I did the math this time. So, goes 10 seconds, then burn. So he says he did the math this time. So did it actually look at what it learned ahead of time and say this is the path to follow? I don't know. So, it's been pretty cool. I've had to create 8080 assembly skills for Claude. Created an 8080 optimization skill. It actually has done a really good job. We helped it create a library for the Dazzler video card. They can do things like set pixel and draw lines and draw boxes and filled circles, etc. And then we optimized that using the 8080 optimization skill it learned. It got about a 4x improvement in speed, which was really interesting. And it's very fast. You get on a 2 megahertz 8080 drawing on the screen in the test demo. And then that was used as the foundation to write Tetris on top of. And I also implemented Conway's Life using that library. And again, it's highly optimized code, and it runs pretty quick. Again, for a 2 megahertz 8080, you don't expect a lot, but it actually performs fairly well. So I think this is, yes, 9th iteration's coming up. He's still coasting. I think he said he was going to do 10 that were coasts. Yep, there's iteration 10 was 0 fuel. Exactly, it's calculated 250. Now the controlled burn phase, burn 20 first to start showing without overdoing, or slowing without overdoing. Because you want to slow down lunarly until you're right above the surface at 0. The original lunar lander had landing probes off the bottom of the feet that were several feet long. And it was one or two of those probes had to contact the surface, then it shut off the engine. The LEM was very close to hovering at that point, and it just dropped those few feet to the ground. And of course, gravity on the moon. I think it's just landed successfully. So it took it 3 tries to actually land successfully. So, that's why there was a human being on board. Those of you who've watched Apollo 11 or studied it know that Armstrong took control and hovered due to rocks in the original landing site, and hovered to find a good spot to land. So 4 feet, 2 feet per second down. If you listen to the audio of any of the Apollo landings, you'll hear the pilot's doing his thing, and the other guy in the LEM is calling out 2 feet per second down, and calling out horizontal motion as well, and altitude and stuff. So it's pretty amazing to listen to them communicate as they bring that thing in and land it. So touchdown at 18 seconds, 2 feet per second, 12 units of film rating. You blew it. Your family will be notified. Why 2 feet per second should have been a survivable? Sure, let's try one more time for a perfect 0. It's funny that it even said, wow, it says I blew it. The game is brutal. I think it wants an even softer landing. Of course, we could look at the source to determine how soft a landing it needed. Maybe this is a bug in the code. I have no clue. If this fails again, I'll have it look in the code to see what it thinks. So we're about 20 minutes into this recording. If you're still watching, I appreciate it. I'm guessing right now it's doing the math again. Try to come up with a little cleaner way to burn. pretty amazing. It's just amazing to me that you can do this kind of stuff. I started playing with Claude Code a month ago, maybe. It hasn't been that long. Talking with a friend of mine, who's been using it for a lot of stuff. And he kind of pointed me at a way to get started on it. And the new skill builder, so there's been a new skill builder in the last week, I think maybe a week and a half, that's much more comprehensive skill builder. And it can spawn off multiple threads, to each do independent bits of work. And it's interesting to watch it do all this parallelism for work and then bring all those pieces back together and then test what it's built and discover bugs in what it built and then go back and correct those bugs. And the skill builder gets to the point where you then come up with a list of tests to actually be ran. And it's just very interesting to go through the experience. Yesterday I had it build a skill for what? It's not going to come to me. It will here in a second. We built a skill. We created multiple tests. Oh, it was a skill to read the Kremenko D+7 AIO card. So that's an S100 card that has a single digital port on it that is 8 bits wide, so it's just a single byte port, and it's got 7 digital to analog and 7 analog to digital ports on it. And so we wrote a skill to be able to read a couple of the D to A's. D to A's? Yes. A to D's, read a couple of those with joysticks attached and actually track the joysticks and to read the digital port. And so we got down to creating the tests for the skill. Had it write 4 different programs, and 3 of those worked first time. We didn't have to tweak anything. So it read the manual for the D+7 AL card, did a really good job understanding it, did its first pass of code, came back from what the agents had learned, applied all of that, cleaned the code up, and like I say, 3 out of 4 worked first time. I was amazed. It got the binary to voltage conversion done. It runs from like minus 2.56 to plus 2.54 volts, I think. It's a bipolar A to D, and it got all the scaling correct, I guess is what I'm trying to say here. First time I was really amazed. It made a mistake up front about what ports the card was on, and it corrected those by feedback from one of the agents as it analyzed online documentation. I pointed it at local documentation as well. So just an amazing experience over a half hour to come up with a skill that knows how to control that card. I then used that skill to modify the, I'm not scrolling here for you, the Tetris code, so I could use a joystick to control the piece. And that actually, first pass of that worked really well, and I had my highest score ever using a joystick. So again, pretty amazing. I was using 4 buttons on a joystick for rotate, right and left. So I'm spending too much time looking at this. 37.5 feet, 35 feet per second, 70 fuel left, plenty of fuel to break that out. It burned 30. This should, drop down about 15. It needs to burn, I say 30. It's going to take that actually, no, I was going to say it would be positive, but it wasn't exactly as calculated. Now coast 1 second to build up a little speed at 9.5. 6 feet per second, and now needs to burn at least 11 and bring that to 0. Wow, altitude of 0.5. Oh, it can do 0.5s. Okay. At 5 feet per second, boy, it needs to knock that off. Out of fuel, touchdown at okay, it's going to come back and say try again, and I'm going to say no and have it look at the source code to figure out what velocity is a winner. So we'll let this do its thing here for a bit. I am on a subscription plan for Claude Code. I'm spending $100 a month which gets me enough time to be able to do all this work I'm doing, because I am spending 8 hours a day playing in this environment, trying to get a handle on it. And this is a complete hobby thing for me. I'm retired. I'm just having fun. So, family will be notified by post. That's just too funny. This game predates email. It predates text messaging. It predates cell phones. I think the first cell phone wasn't until in the 80s. Yeah, I think it was in the 80s, 82, 84, someplace in there. Oh, I don't want another mission attempt. If I can get it to stop the mission. Okay, decline another mission. I don't know where we are sitting at the moment, whether we're sitting at the, okay, we're back to the basic prompt, breaking 500. Exit MBASIC to CPM. Don't know why I wanted to go back to CPM, but we'll let it. We're back at CPM. Brutally stinging with this phrase. Okay. Please review the Lunar source code to see what velocity is a winner. So, not exactly sure what it's trying to do there. Oh, Lunar.basic's in ASCII, so it was able to type it out. So, greater than 5. If it's less, it's got to be less than 2. 840, print, another mission. So, it's exactly 0.0 feet a second. Then 810. Oh, I get it. It needs to be 0. If it's greater than 0, so it's got to, yep, I see it. Well, we're going to let it try again. So we can see in the code it's got to be an exact 0. V1's not 0. Go to 810, otherwise print U1. Perfect license is renewed. So, and then it's looking at absolute velocity here. If it's less than 2, then 840. That's pretty wild if absolute's less than. So, wasn't a perfect landing. Okay, at 840. So, sorry, I look like we're into coming up on a half hour in this video. It's a long video. I apologize for the length. If you made it this far and you're still trying for a perfect landing, or hoping we get a perfect landing, I appreciate it. I intend to do a couple more videos. Claude can write really good assembly code. At least it looks really good to me, and I'm going to have it probably use the editor and write a hello world in assembly and assemble and convert it to COM file under CPM. It's not really linking at that point. I think I'll probably just use the straight Mac or ASM.com programs to do it, and then have it write hello world in BDSC. We created a BDSC skill. It understands the limitations of BDSC. It should be able to write a hello world in it. So, like those will be separate videos from this. If there's something you want me to try, throw it in the comments. I can certainly give it a try. I'm not scrolling here in real time, sorry. Yes, I want to see a perfect landing. And say, I've never pulled this off. And remember back in the late 70s, probably 79, I was a computer tech, contracted to the Air Force doing basic maintenance activities on mostly deck hardware, which is cleaning tape drive heads and running diagnostics and if replacing cards if a card was bad. I did a minimal amount of component level troubleshooting. It was very small. We typically swapped cards, all those kind of chores. And one of the machines, I want to say it was an 1140, may have been the 1177, had a graphics terminal. I want to say Tektronix, but I'm not sure of that. It may have been DEC. That was monochrome, vector. I'm sure it was vector graphics. There was a lunar lander, and you used a light pin to interact with the code. And if you got a successful landing, the little astronaut came out of the LEM and moved over to a McDonald's and ordered like a Big Mac meal. It was very cool. It was a lot of fun, and that was part of running diagnostics. Was a couple passes at the game every week. So let's see if we get a perfect landing. Lots of fuel left at this point. Congratulations, a perfect landing. Yes. That's very friggin' cool. Well, 4 attempts. So it did something I've never pulled off, and that is land lunar lander successfully. So it's moved back to the command prompt. Mission accomplished. It's just so awesome. So I'll wrap this up here. Like I say in the beginning, I think this is the first time this has ever been done. If it's not the first time, let me know. Point me at whoever's content. Beat me to the punch. Anyhow, hope you enjoyed the video. A like would be appreciated. Share it out if you want to share it. I appreciate it. Appreciate all of you. We'll talk soon.